Today we'll look at using components to add vectors. So using components is just another method of adding vectors. We have done tip to tail, and today we will do components. So when you have a vector, let's say this is vector v. Let's put the pen on here. So let's call this vector v. We can divide the vector into a triangle. So this is a right angle triangle, and the x is called the x component of the vector, and then we have a y component of the vector. So if we have it on this grid, we can just count how many units the x and y components are. The x component is 1, 2, 3 units, and the y component is 1, 2, 3, 4 units. So we have created a right angle triangle, so we can use Pythagorean theorem to solve for the magnitude or the length of vector v. So we'll just put those values into the Pythagorean theorem, and we would result in a magnitude of 5. We can also find the angle that the vector is directed by using tan. So tan is opposite over adjacent. In this case, the opposite side is 4. Remember that we're looking for this angle here. And the adjacent side is 3. If we use inverse tan of 4 over 3, we will get an angle of 53 degrees. So you can find the x and y components of a vector individually just by creating a triangle, a right angled triangle, and calculating from there. So here we have two vectors, w and v, and we're just looking for the components. Vector w is headed directly along the horizontal. So we can count 1, 2, 3, 4, 5 units, and is going left. So I would put -5. And then the y component would be 0 because it's neither going up nor down. If I were writing it in component form, I would put -5 for the x component and 0 for the y. V is going left and down. Note the arrow. So the arrow is going this way. So again, I'm going to count 1, 2, 3, 4. 4 units for the x going left. And the y is 2 units going down. So again, both negative. Negative describes the direction that the vector is going. So we're saying it's going left 4, down 2. We can also look at a vector that is in a quadrant. It wants us to measure the vector w from the positive x-axis, which is this axis here. This is the x-axis in the positive position. And then we always measure counterclockwise. So 152 degrees would be in this direction, and that would result in our vector w. And we know vector w has a magnitude of 10. So we're asked to find the x and y components. We always create the triangle by connecting to the x-axis. So we'll draw a line down to create a triangle, and we're looking for the x component of w and the y component of w. This means that we need this angle, this related angle, between vector w and the x-axis. So we can find that by subtracting from 152, because they are supplementary. So it'll be 28. I'll write this here. So this angle here is 28. This is the angle that I will be using. Always connect to the x-axis. So the x component is adjacent to the angle. So we're going to use cosine. Adjacent over hypotenuse. The angle that we are given is 28. The adjacent side is x, and the hypotenuse is the magnitude of 10. The y component is opposite, so we can use sine. And the angle, again, given is 28. Opposite is the y value, and we will use the magnitude of 10. So in order to find x, we will just cross multiply. 10 times cosine 28. And y will be 10 times sine 28. And then we can just type that into the calculator. 10 cosine 28, that is 8.8. And sine 28 is 4.7. Now, if I'm writing in component form, I'm going to put it in brackets. The x is going left, so we're going to indicate that by putting a negative, and that describes the direction. So we're going left 8.8, and then up 4.7, so that will be positive. We can also use vectors to solve questions that we did previously by tip to tail. Previously, we added two vectors by placing them tail to tail. So let's say we have these two vectors. One is 32 newtons and one is 26. And the angle between them is 107. So previously we did tip to tail. So we would place this 26 tip to tail with the 32. And then we would have our resultant vector here. And we would use the supplementary angle to 107, which is going to be 73. And then we would use cosine law. So the resultant would be 26 squared plus 32 squared, and so on. So we're going to use the cosine law to solve for the resultant. And plug that into the calculator, you will get a magnitude of 34 points, I'm going to say 8 newtons. And then we could find the direction by using the resultant that we found, 34.8, which is opposite angle 73. We want this angle here, so we'll use the 26, which is opposite that one. And then we'll be able to find the angle of the resultant. And that angle works out to be approximately 46 degrees. And we're measuring that from the 32 Newton force. So that is tip to tail that we did previously. We can also look at the two vectors individually and use components. So we have a 32 Newton vector that is placed, we place that horizontally. So we're going to look at the x component and the y component. Since the 32 is placed horizontally, it will be 32 along the x and 0 on the y because it's neither going up nor down, and it's going to the right, so we have positive. The 26 Newton vector, if we make a triangle, maybe I'll do this in a different color. So I'm going to do a triangle connecting it to the x-axis. So we want to use this angle here, which is going to be 73. That's the angle that connects the vector to the x-axis. So maybe I'll just draw a separate diagram here. So the 26 Newton force was 107 degrees from the 32. So we're going to make a triangle. We want to find the x and y components. And the angle that we will use is the angle that connects the vector to the x-axis, which is 73. So magnitude is 26. The x component will use cosine of the angle. And magnitude is 26. We'll use sine to find the y component. The x component is going to work out to be 7.6, and it is going left. So that will be negative. The negative indicates that the x component is going left. Y will be positive because it is going up. So 24, I'm going to say 9. And then we're just going to add it up. So we found the x and y components individually for the two vectors, and then we're going to add them up. So we're going to do 32 minus 7.6 is 24.4, and we'll do 0 plus 24.9. So what we've created is the resultant. These are the components of the resultant. They are both positive, which means that the resultant is going right and up. This is what the resultant's going to look like. 24.4 on the X and 24.9 on the Y. And you can see from the original diagram when we did tip to tail, you can see that the resultant goes right and up. So with my total, I can find the location of the resultant just by looking at whether it's positive and negative. So now we've created a right angle triangle with the resultant, so we can use Pythagorean theorem to find out the magnitude of the resultant. So we'll use these two values here that we just calculated, and we'll find the magnitude of R. If you plug that into the calculator, you'll find that it works out to be 34.8, which was the same result that we got using tip to tail. So some students like to use components as a check when they're doing tip to tail to double check their answer. You can choose either method. There will be some questions where you'll have to find components, but it does give you an alternate option of finding the value of the resultant in a different method. So tan, we're going to use opposite over adjacent to find the angle, and that works out to be 46. Again, the same answer that we got using tip to tail. This question here is open to interpretation when you draw your diagram, but we're going to use components because there are 3 vectors, and components are useful when we have more than 2 vectors. So the instructions say that we have 3 vectors, V, U, and W, and it says V lies between U and W. So the magnitudes are given respectively, so I'm just going to label them as V being the first one mentioned, so that will be 4. U is the second vector mentioned, so that will be 6. And W will be the third vector mentioned, so I'll make that 2. It is open to interpretation. Some students think that U should be 4, V is in between, so that should be 6 and 2. Usually we'll base your solution by the diagram that you've drawn. So if your solution matches the diagram, then we're good to go. Always, if they don't give you a starting point, always place one of the vectors on the horizontal. So I'm going to put U on the horizontal. It says V is in between U and W, so I'll put V next and then W. So it says V lies between U and W and have magnitudes 4, 6, and 2 respectively. So I've decided U will be 6, V will be 4, and W will be 2. The angle is 40 between U and V. So this angle is 40 degrees and 10 degrees between V and W. So there's my diagram. So my solution is going to be based on the diagram that I've drawn. I am going to make a table to do my X and Y components. So I'm going to put U. U is on the horizontal. X will be 6, Y will be 0. It's headed in the positive direction, so that one's easy. V is at an angle of 40, connect to the x-axis. It has a magnitude of 4, so cosine of 40 and sine of 40. Again, both positive. And then W has a magnitude of 2. W, the angles that we're going to use is 50, because when we make a triangle, we will add the 40 and the 10. So that will have a magnitude of, or an angle of 50. Once we have that set up, we will just determine these values and then total them. So this one I just put in here just because The diagram needs to be interpreted. And again, it will be based on how you interpret the description. That is up to you, which vector has which magnitude. But I will look at your solution based on the diagram that you used, right? So it should match the diagram that. So we'll put these values in here and then we'll just total them up. So the total for the x is 4.35. Total for the y is 4.1. And then we can just use Pythagorean theorem to find the resultant vector. I don't really need. Okay, so we've got 4.35 squared and 4.1 squared to find the resultant magnitude. And we get a final magnitude of 5.98. Okay, and then with direction, you can just use tan with the resultant components. So we'll use tan of 4.1 over 4.35 to find the angle. And we can calculate that to be about 43 degrees. So this one is not too tricky, it's just that we sometimes need to interpret the description. If there are no starting angles, always place one vector on the horizontal. That just makes it easier than placing them not on the horizontal. Then you're going to end up with 4 vectors. Okay?